The topic is capacitors. So first let's recall the formulas related with this topic. So Q is equal to C times V. This is one formula that we use. And the next one that we use is C is equal to epsilon times A divided by area, and this is D, distance between the two plates. Now let's start solving the problem questions. So if you see the first question, it says here you need to find the charge stored on either plate of a capacitor which is of value 4 into 10 raised to minus 6 farads, and then it is connected across a 12 volt battery. So let's write down the value, which is C is equal to 4 into 10 raised to minus 6 farads, and then voltage is given, which is 12 volts. And then it's asking you to find charge, which is a question mark. So Q is equal to C times V. Now applying the values into this formula, you would get Q is equal to 4 into 10 raised to minus 6 farads times the 12 voltage. And the answer would be 48 times 10 to the power minus 6. And charge is always measured in coulombs. Now let's move on to the next one, which is if the plate separation for a capacitor is 2 into 10 raised to minus 3, determine the area of the plate if the capacitance is exactly 1 farad. So we know that the capacitance is 1 farad, and the plate separation, which means the distance between the two plates is 2.0 into 10 raised to minus 3 meters. And then it's asking you to calculate the areas of the plates. So let's start doing this now. So capacitance is 1 farad, and then the distance between the two plates is 2 into 10 raised to minus 3 meters. And then it's asking you to calculate the area. So what do you do now? So if you go back to the formulas that I explained you earlier, this one, you would be using that, which is C is equal to epsilon times area of the plates divided by the distance between the two plates. Now we don't know area. Yes, we need to find area, and we make area as the subject, and we have the values for C and we have the values for D, and epsilon is understood because it's in vacuum, which is automatically the value is 8.85 into 10 raised to minus 12. Okay, so that is the value for epsilon. Another thing I missed is this is epsilon 0. Okay, so yes, and now keeping A as the subject on one side of the equation and moving these two into with the C, what you do is C times D. I don't need to explain you this because this is basic mathematics, so you should be knowing by now how to rearrange formulas. Okay, so if you keep A as the subject, these two quantities go into this side of the equation. So C times D divided by epsilon 0. And now what is C? 1 farads. And what is the distance? 2 into 10 raised to minus 3 meters. And then what is epsilon? We already know it's a constant value for air and vacuum. And that is 8.85 into 10 raised to minus 12. Now solving this should give you your area. And that is 2.3 into 10 raised to 8 meters square. So this is your area. Okay. Okay, now moving on to the third one. Okay, so this is a bit moderate level of a question. So you need to calculate the voltage of a battery connected to a parallel plate capacitor with a plate area of 2 centimeter square and a plate separation of 2 millimeter if the charge stored on the plate is 4 picocoulombs. So charge is given, which is 4 picocoulombs, and the area is also given, and the distance between the two plates is given, and you need to calculate the voltage. So this is a bit tricky, and you need to think about how you would solve this. Okay, so now if you see, you can see here, you need to calculate the voltage, and the area is 2 centimeter square, and the distance is 2 millimeter, and your charge stored on the plates is 4 coulombs. So let's start first recording the given information. So your charge stored is 4 picocoulombs. So remember, I said you what pico is. It is 10 raised to minus 12. So you need to always convert picocoulombs to its standard format, which is 4 into 10 raised to minus 12 coulombs. And that is your charge. Now the next one that is given is the area of the plate, which is 2 centimeter square. So area is equal to 2 centimeter square, and you know that you need to convert this also into its standard format. So it is going to be 2 into 10 raised to minus 2 meter square. So it is going to be automatically minus 4. And then the next one that is given is the distance, that is the separation of 2 millimeter. The distance between the two plates is 2 millimeter. So D is equal to 2 millimeter. So again milli is 10 raised to minus 3. If you don't recall this, please look into the blue book that I've given before, or you can look into the LJ Create multiples and submultiples PowerPoint, and you will know how to convert these. Okay, so milli is just times by 10 raised to minus 3 meter, and this is your distance. Now it's asking you to calculate voltage. So we need to calculate voltage, and we don't know. So we know that there is one formula to calculate voltage, which is Q is equal to C times V. So can we use this? Because we have Q and we have been given, no, we are not given C. So we cannot use this formula because we only have Q. So C is not there and voltage is not there. So the next thing that you would do is to find C, and the other formula to find C is epsilon times area divided by distance. So using this formula, you can calculate and find out C. So once you find out C, you can apply it into this formula and get the value for voltage. So C is equal to epsilon times area divided by V. So epsilon is 8.85 into 10 raised to minus 12. And the area is, so if you scroll up, you can see area is 2 into 10 raised to minus 4. And then the distance is 2 into 10 raised to minus 3. And then just straight away put this in your calculator and you should get your value, which is 8.85 into 10 raised to minus 13. And this is your value for C. So once you've got the value for C, now you need to find what is voltage. So C is given, so you have C, and now you can use the formula which is Q is equal to C times V. So now your Q value is given, which is 4 picocoulombs. So 4 into 10 raised to minus 12. And then your C is 8.85 into 10 raised to minus 13. But your voltage is not known. You need to find your voltage. So you need to make your voltage as the subject. So you keep voltage on one side of the equation and then you bring this number with this. So it's going to be 4 into 10 raised to minus 12 divided by 8.85 into 10 raised to minus 13. And then, so every time you put these two arrows like this, it just says that this is the next step. So make that as a good habit of solving problems. So V is equal to, now once you solve this, you should get your answer as 4.5 volts. So this is your final answer. Now let's look into the fourth question. So this is also an easy question. So here you're given a parallel plate capacitor with an area of 0.2 meter square and capacitance is 7.9 nanofarads, and then it's asking you to find the plate separation distance. So automatically you understand that you need to find distance between the two plates. So moving on to your fourth question, capacitance is given, which is 7.9 nanofarads. And then it's asking you to find distance. So we don't know distance between the two plates. It's a question mark. And then it's given you area, which is 0.2 meter square. And then that's it. So now it's asking you to find the distance. So again the same formula, C is equal to epsilon times area of the plate divided by the distance between the two plates, and you need to find the distance. So you're going to keep the distance as the subject. So I'm going to make distance as the subject and the rest stays as it is. And C comes down. Now rearranging the formulas, I'm going to put the value. So epsilon is 8